Okay, guys. Hey, welcome to a different way to look at straight lines or linear functions. And I highly encourage you to go ahead and print out the notes here while I'm making a video for you. See how far we're getting on this video. And before we get going, though, I kind of just gave you the the shorthand version of it's just going to be about straight lines, but really it's y equals mx plus b. And the big words about on how to do all this stuff and apply it to some real world settings. It's called modeling linear functions with tables and graphs. So stick around, hold on tight, and really you can read the why and these learning objectives later in more detail if you'd like. But really, if I'm kind of picking off of the writing that you see in front of you there, there's all sorts of numbers and numerical data that's in the stock market and inflation trends and military spending and the internet and banking and all sorts of stuff and all sorts of needs to organize information into models like real life models. And while we've been practicing some mechanical versions of how to do equations of lines, we're going to finally start to put it with some words. And I know you guys all hate word problems, so I apologize up front, but there's no getting around them. So my whole attempt is just to try to make the word problems easier for you and help decipher them. Because if we can do that, find a couple things, you'll find some success. So first off, look at the learning objectives. And some of this you might have done earlier in the week or earlier in the course already. But pretty much, we're going to learn to communicate, problem solve, and the big one for me is multiple representations. We're going to do it different ways to find straight lines information from tables and graphs. We can go down to skills and talk about finding the equation of lines. And, eventually, the whole goal here is to be able to have you work with somebody and communicate your ideas in groups. But right now, let's just go ahead and kind of get started here with the warm up. We're just going to go through as far as we can here and try not to make it too long, but it's kind of hard to do sometimes. So if you get tired, just pause the video, come back, remember where you fell off. And so here we go. So the first question is asking what's the general equation of a line? And really, if you remember from back in the day, as my computer and I try to get synced up here, it's y equals mx plus b. So again, hopefully you've already printed out these notes. They should be accessible. Um, and you can kind of take notes on this as we go along here. So y equals mx plus b is the equation of a line. And anytime you hear the word linear, that's going to be kind of an indicator that you can use this form. It's also the same form that you're going to need um, on a calculator. So everything usually will be solved for y. Now, really, the letters in here, x and y, will be called the variables. And those are the things you don't know. M is going to be defined as the slope. Okay? And the slope is really, and I might be telling you too much here, but our definition, if we haven't talked about it already, it's a comparison of two quantities. So what mathematicians like to say is they like to say it's a change in y over a change in x. What I like to do is I call it the change in rise over run. And I used to say I used to have to rise up or down, I guess, before you went for a run left or right in the morning. Remember, it's a comparison between two things, and you use it all the time. It's like, um, you know, uh, gosh, how fast you're going in your car. We usually talk about miles per hour, or how many calories per day. That word per is just a fraction. So, if I'm taking this one step further, my formula for this when I have points is y2 minus y1 over x2 minus x1, and this should be review. So, in other words, you might have seen it, might have forgotten it, but you should have at least seen that in Algebra 1 at some point in time. So this is a lot of refreshing, sorry, for applying all this stuff to word problems. So we already talked about x and y. M is the slope. B is going to be called maybe you're finishing my sentence, the y-intercept. And you can write it as 0 comma b if you want, but most people just remember that m is the slope and b is the y-intercept. Okay, those letters are constants. They don't change. So for number 3, we don't have to fill out all of these. This is, again, just more review, trying to get everybody caught up and on the same page. What does it mean to say a letter represents a constant? You're just saying the letter is represented by some number, and it's not, in other words, the values don't change. That's what I would write there. But just for time's sake, I'm going to kind of glaze by that one. So the variables, we've already told you which letters are variables. Those are X and Y. And the variables are called variables because you can change them. They're values that can change over time. And, in other words, if you were driving, you could drive 5 miles, or you could be in the car, for 10 minutes and drive 5 miles, or be in the car for 20 minutes and drive 50 miles. So the values can change as you go forward there. When you're asked to define your variables, usually your problem will come in some kind of context. Right now, the verbiage I've been using is miles per hour, and X would be, in my context only, because I'm making it up. X would be miles, and then Y would be. I'm sorry, I'm saying that wrong. X would not be miles. X would be time. So please forgive me on that one. X would be time, and Y would be miles. If I were talking about driving somewhere, miles per hour. And it is possible to flip flop those at times, called invertible situations. But for right now, we'll define our variables later on, and let's just see if we can do this part, number 5, before we do anything else. Just mechanically, if you were asked to get the equation of a line that fits each description, that has a slope of 2 and a y-intercept of 3, again, the only things you need for the equation of a line are those two constants, meaning those two numbers that aren't going to change, and then X and Y will be the variables that do change. Depending on what you plug in will depend on what you get out. Just like I like to call it a function machine, or a Coke machine, if you've heard me talk about that before. You plug in $1, you can get out a soda. You plug in $2, you get out a Red Bull. So what you plug in depends on what you get out, which is, you know, pretty much the definition of a function. So we're going to get a function here, and you can do it y equals mx plus b if you like. And other professors, myself included, prefer function notation, which I think you might have seen already. And it means the same thing. This is just meaning f of x, or function evaluated at an input of x. Fancier way of saying the same thing. So again, we need to figure out my m and my b here. And to do that, if it's staring you in the face that the slope is -2, please feel free to plug the -2 straight in. And the y-intercept of 3 is going to go here, in this spot here. And then you'd be done. Now, you could write this a variety of ways. I don't know if my eraser is going to work quite right here. But you could, with the correct notation, put -2x plus 3. Or you could write it, 3 plus a -2x as well. Whatever value is touching the x is always the slope, okay? And for that matter, if you want to make sure you know it's a slope, you can always write it as a fraction if you like. Most people don't, but make sure that you understand that the slope is a comparison, again, of two quantities, and the slope over here, I should write in, gosh, notes are going all over the place. It's an average rate of change. Sorry for how sloppy it is, but that's what slope means. In other words, driving, if I told you I was driving to San Francisco, and San Francisco was an hour, 60 miles away, and it took an hour to get there, my average speed would be 60 miles an hour. Doesn't account for the fact that I went slower in some spots because of traffic, or faster when I was speeding. Okay, let's do one more and we'll stop this video here. Give me the equation of a line. So automatically, this f of x is going to equal mx plus b. And I need a slope and a y-intercept. Now, if I need a slope and a y-intercept, the slope is already there. So if you're lucky enough to get the slope, take it and jam it right where the slope's supposed to go. Now, the hard part here is that I don't know the y-intercept. This is just a point, the negative 2 comma 5. So to get the y-intercept, remember, this is like my y value here. And again, I'm not trying to confuse you, but remember, you're going to, see that in the future. So for now, if you wanted to solve for your y-intercept, meaning this value b, all you have to do is plug this value in for x and this value in for y of your function. So if we go ahead and do that, this value y here is going to be negative 5, 1.5x, which is x is negative 2, plus a b. Now, I'm running out of space here, but if I just keep carrying this down, negative 5 is equal 1.5 times negative 2. Well, I think that's going to be what? Negative 3 plus a b. And then as long as I solve for b, get it by itself, your b will equal negative 2. But you see how that happened? Now you're not really done quite yet. You knew the slope, which you put here. Oh, goodness. And now you know the y-intercept. So no matter how the problem comes at you, you need to finish strong and write a final sentence saying, hey, my slope is 1.5x plus your y-intercept. The more correct way to write it, f of x equals 1.5x minus 2. So there's an intro for you. We'll stop that video here, and then we'll pick up and do the group exercise probably in the next one. So go ahead, review this as needed, and I'll see you in the next video to do the next problem. Go ahead, take a look at it if you can, and I'll help you out with that too.